to tell you a little story about two planets. One planet is the planet of normal numbers. Here we have this red planet here. The planet of normal numbers. That planet had living creatures on it called normal numbers, such as 0, 1, 2, 3, 4, 5, 6, 7, 8, and so on. And they even had negative numbers such as -1, -2, -3, -4, and so on. They also had fractions on that planet, such as half, 1/3, 2/5, all kind of different fractions. They even had negative fractions, like -half, -1/3, and -2/5, and so on. Now, on this planet, every number here had a partner, like it was married, a partner, and the partner was called its inverse. Now, when the two numbers came together and they multiplied, they would produce, because when you multiply, you get a product, right? So they would produce the identity number, which is 1. For example, here, the inverse of 2 is a half. A half times 2 equals 1. And the inverse of 3 is 1/3. When 1/3 multiplies to 3, you get 1. All numbers had a partner, also known as its inverse. All the numbers except the number 0. 0 had no inverse on this planet. So you could say he was single forever. If we try to find the inverse of 0, 1 over 0, on your calculator you'll get an error. In maths we say we have no answer, or the answer is not defined. So on this planet, the only single guy was 0. Everybody else married. They had a partner. Let's compare now the planet of 2 by 2 matrices. On this planet, we'd have a lot of matrices. For example, let's call one matrix A, which was 1, 2, 2, 6. And let's imagine the next matrix called B, which was like 1, 3, 2, 6. And many, many, many more matrices, of course, because you could have all kind of different numbers in those brackets. Now, on this planet, every matrix had a partner called its inverse. In other words, every matrix was married. They have a wife or a husband. And when the matrix was multiplied to its inverse, they would produce the identity matrix. Just like how you have the identity number 1, you would produce the identity matrix I, which was 1, 0, 0, 1. Now, all matrices had a partner. That means all matrices were married, except for those that were singular. Obviously, if you're single and you're married, you have no partner, right? The singular matrices had no partners. That is, they had no inverse. They were single forever. Let's look at an example. The same matrix A which I showed you earlier, 1, 2, 2, 6. It has an inverse. Its inverse is 3 minus 1 minus 1 and a half. So the inverse of A multiplied to A would be the inverse of A multiplied to A, and you'll end up getting 1, 0, 0, 1, which is the identity matrix. So this one had a partner, not singular. However, look at matrix B. Matrix B had no inverse, since the determinant of B was 6 take away 6, which is 0. Look at it here. Matrix B. 1 times 6 is 6. 3 times 2 is 6. 6 take away 6 gives you 0. B had no inverse. So the idea is that when you see the word singular, it means the determinant is 0. It also means that the matrix has no inverse. And another thing to take away from the story is that the meaning of the word inverse, the inverse is a partner. It's something when you multiply the original to its inverse, you end up getting the identity matrix. Or if it was just plain numbers, you get the identity number. You basically get 1. The number 1 or the matrix version of 1. The end.